Hello students, good morning, good evening and good night. Depending on which time we are going to observe this lecture, welcome to the 7th lecture on aldehyde, ketone and carboxylic acid chapter. In this lecture, we are going to discuss the preparation of carboxylic acid. So heading of today's lecture is preparation. Important thing, that is the preparation of carboxylic acid. Carboxylic acid, both aromatic and aliphatic, that has been produced by different techniques. The most well-known method, that is first we are going to discuss, this is the oxidation of primary alcohol, or we can write 1 degree alcohol and aldehyde. This is Kekem Karchi, the science with Mukari Sari to chat. When we are talking about the oxidation, naturally we have to be very much cautious about the oxidizing agent. The general reaction, that is formation of the alcohol into the carboxylic acid, is like this. This is alcohol, 1 degree alcohol, and it has been oxidized to carboxylic acid, which is having this. The number of carbon atom is same. When we are talking about the primary alcohol, the number of carbon atom will be same in the carboxylic acid, produced carboxylic acid, and it is same as the alcohol. Here the oxidizing agent which is used, that is, we know, that is we can use different oxidizing agent, that is alkaline KMnO4. You can use the acidic potassium dichromate K2Cr2O7, or chromium CrO3, chromium trioxide. That all you can use to oxidize this alcohol into the carboxylic acid. Another, that is important also, when we want to convert the aldehyde into the carboxylic acid. In this case, the difference is that here oxidizing agent is mild oxidizing agent. We can use the Tollens reagent, or we can use filling solution, and others also we can use. So this is the first way, that the most common way to convert to produce the carboxylic acid from other hydrocarbons, that is from the alcohol and aldehyde. Second, that is again a very important thing, and it is the oxidation of alkyl benzene. In this process we will produce the aromatic carboxylic acid. Oxidation of alkyl benzene, and it's required some very vigorous treatment. You need the oxidizing agent, that is alkaline KMnO4, or you can use the acidic K2Cr2O7. In this case, what is going to happen? Let us see one reaction. This is toluene. Toluene is a alkyl benzene. This is toluene, and when it is KOH and KMnO4, it is going to oxidize and The side chain will produce the potassium salt of the benzoic acid. So in this we can produce this, and when this is hydrolyzed in acidic solution, in acidic condition, it will going to produce the benzoic acid. The side chain can be, it can be ethyl, it can be isopropyl, it can be tertiary butyl, and the result will be the same, that we will going to produce the benzoic acid. This is benzoic acid. But when we are trying to understand the reaction, it is, you will find that toluene will have the higher reactivity than ethyl benzene, and ethyl benzene will higher reactivity than isopropyl benzene. Isopropyl benzene, and this is again higher reactivity than the tertiary butyl benzene. Tertiary butyl benzene. Tertiary butyl benzene. So reactivity is highest and warmest, weakest in case of toluene, but all the side chain will be converted into the benzoic acid when we use this oxidizing agent. Now, third reaction that we are going to discuss is again a very important reaction. This is the carbonation of Grignard reagent. Carbonation of Grignard reagent. Grignard reagent. Here dry ice is reacted with the carbon dioxide, and it will going to produce after hydrolysis the carboxylic acid. The reaction is this. This is the Grignard reagent, and here carbon dioxide is, this is a carbon dioxide, and we know Grignard reagent, that is basically it is there is a two pole that is created. One pole, that is, this is the minus, and here magnesium is a plus charge. So this alkyl group will be attached to this carbon atom, and it will going to produce a additive product. This is a additive product, MgX, and when we hydrolyze in presence of H plus ion, that is going to produce the carboxylic acid, and byproduct you can see XOH. So carbonation of Grignard reagent also we can able to produce this carboxylic acid. This is the reaction. Now that is a fourth reaction we are going to discuss. That is again a very important reaction, that is the Koch reaction. Koch reaction. Koch reaction in this case with olefin. When we react with the carbon monoxide in presence, and it is being heated in presence of a steam, and there is a catalyst we have to use, it is going to produce carboxylic acid. Let us see the reaction. We are taking the ethene. This is ethene. ethene has been reacted with, we will say it is reheated with the carbon monoxide and steam. In presence, the temperature has been kept 573 Kelvin to 673 Kelvin, and here the reaction is undergo under pressure. We can write is under pressure. Under pressure reaction is going on, and there is a catalyst is also being used. Catalyst is H3PO4. So it is going to produce acid, that is propionic acid. This acid is going to be prepared. And with this process, again, if we take this propene with carbon monoxide and H2, and under the same condition, it will going to produce this carboxylic acid. This is the 2-methyl. This is 2-methyl propionic acid. Here it is a propionic acid. Propionic acid. Here 2-methyl propionic acid. 2-methyl propionic acid. Okay, so this is a Koch reaction. So we understand 4 reactions by which we can able to produce the carboxylic acid. That is, we are going to discuss. It is between the sodium alkoxide, and CO, carbon monoxide. In this case, when suitable sodium alkoxide has been heated under pressure, it is going to produce the carboxylic acid. The reaction is alkoxide RONA plus this, and it is react with the carbon monoxide, and it is being heated, and under pressure, there is a specific pressure has been maintained under pressure, and it is going to produce a carboxylic acid, and this is this. Not directly carboxylic acid, it will first produce the sodium salt of this carboxylic acid, and after that, when we hydrolyze it in presence of acid, it is going to produce the carboxylic acid. In this process, we also produce the formic acid also. At that time, we are going to take NOH and carbon monoxide, and temperature has been kept 473 Kelvin, and pressure has been kept 8 to 10 atmospheric pressure. In this pressure, you will going to see same way, that is the salt of sodium formate, and again there is hydrolysis, and it is going to produce formic acid. Next, 6th, that is a very important, hydrolysis. Hydrolysis of nitriles. Hydrolysis of nitriles. In this case, the hydrolysis can be carried out in presence of acidic hydrolysis, in presence of acid, or it can be carried out in presence of OH minus, that is in the alkali. When in presence of acid, it will going to create the ammonium ion, and in presence of OH minus it will going to create the ammonia. So let us understand the reaction. We have taken this acid, this is acetonitrile, and this acetonitrile when been hydrolyzed in presence of H plus, hydrolyzed in presence of acid, it is going to create amide. First it will going to get amide, and when we further hydrolyze it in presence of acid, it will be going to create this acetic acid, and also it will create the ammonium ion. So this is acetamide, and it is acetic acid. Second reaction, in presence of alkali, we are taking this C6H5Cn, or we can take this is benzonitrile. When it is hydrolyzed in presence of NOH and H2O, it will going to produce this. We are going to produce benzamide, and further hydrolysis with NOH, it is going to produce the benzoic acid. And it will going to produce ammonia. Okay. So hydrolysis of nitriles, we can also produce carboxylic acid. First it will, the acetamide, amide product will be produced. After that, further hydrolysis will going to give the carboxylic acid. Here it is acetic acid, here it is benzoic acid. Okay. Now the seventh reaction, that is oxidation of methyl ketone. When we oxidize the methyl ketone in presence of excess halogen and alkali, it is going to produce the sodium salt or salt of the carboxylic acid, and which, that is, first this is methyl ketone, methyl ketone when being oxidized in presence of sodium hypochlorite, means halogen we are taking and we are taking this NOH, it is going to produce the sodium salt of carboxylic acid, and it will also perform halo form. It will also form halo form, that is CHX3. And when this is hydrolyzed in presence of H plus, and it is going to produce the carboxylic acid. And here X can be chlorine, bromine or iodine. So 8 number reaction, that is the again hydrolysis of acid derivative. In this case, first hydrolysis of acid chloride. When we hydrolyze acid chloride in presence of normal water, it is being produced, the carboxylic acid has been produced, and it is being hydrolyzed in presence of alkali, it is produced the carboxylate ion, and this is further hydrolyzed, acidified, and it will produce the carboxylic acid. Acid anhydride, when we give water in it, we react with the water, it will going to give the carboxylic acid. Again, another acid product, that is the ester, and when we hydrolyze the ester, it is again going to give you the carboxylic acid. So first, this is acid chloride, and when it is being hydrolyzed in presence of H2O, it is going to produce this carboxylic acid. When it is in presence of alkali, hydrolyzed in presence of alkali, it is going to produce the carboxylate ion, and this is being further being hydrolyzed, or we can say acidified, and it is going to produce this carboxylic acid. In case of acid anhydride, suppose this C6H5, this is benzoic anhydride. When it is being treated with H2O, in presence of H2O, it is going to produce benzoic acid. Another reaction you can see, that is C6H5. This is benzoic ethanoic anhydride. This is in presence of H2O, it is going to produce this benzoic acid and the acetic acid. Okay. Now from the esters, this is the B number reaction for the acid derivatives, and C, that is the from the ester. Hydrolysis of ester, we can also produce this carboxylic acid. As for example, C6H5 COO2H5, ethyl benzoate. When in presence of H plus ion, it is going to produce this benzoic acid and C2H5OH. It is also been hydrolyzed in presence of the alkali also. See this reaction. in presence of NOH, it will produce the sodium salt of, it is ethyl butanate. This ester name is ethyl butanate and it is going to produce the sodium salt or butanate. So it will going to produce CH3, CH2, CH2, COONA. And when it is hydrolyzed, it will produce butanoic acid, CH3, COOH. Okay, so that are the reactions, that is the preparation methods of different carboxylic acid that we have discussed. That is the aromatic as also the aliphatic we have discussed, and total 8 reactions we have discussed, and this will help you in exam. What will going to happen? This type of question will come. You have to put, you have been given everything, but you have to say what will be the product. When suppose it is given, you hydrolyze the nitrile, then what will be the product? When we hydrolyze the nitrile at the intermediate stage, the mild stage, it will going to produce the amide. This type of questions going to ask in the questions, and if you follow this properly, you can able to understand it. You can able to give the right answers. This is basically a service to the students of the class 12 who cannot afford the costly tuitions, because tuitions nowadays are becoming very much costly and normal common man could not able to afford that. So I think this will going to help them if they concentrate on this lecture, and that will be helpful to them. Thank you very much for watching, and we will meet in the next lecture, that is the properties of the carboxylic acids. Thank you very much.